recording. More students joining. Light clock. Let's get the. I just restarted my computer to update my software, my Windows software. It's a good idea that we do that, right? So you don't, so the computer don't stay vulnerable to non-viruses out there. And now I can start sharing my screen. Okay, I didn't finish my, here you go. This one that you see here is supposed to be C prime. Huh? Let's keep the notation consistent. And now we can combine those two equations to find out what is the period that observer, period of the clock C prime that the observer A measured for the clock C prime. Okay, that what's going on here. Okay, one more. There is more. My goodness. Let's not forget that other equation. Okay, here you go. Let's not forget this one here. I'm gonna put side by side next to each other so we can follow properly. Okay, clock C prime as measured, the period of clock C prime according to observer in referential B, clock a period of clock C prime according to observer in referential A, right? So let's write down here, you know. Yeah, not good. Means, okay, period of clock C prime as measured by someone in measured by an observer in referential B. In referential B. And then we have something similar for the other one. Period of clock as measured by an observer in referential A. Okay. So I'm going to plug this equation right in here. Right in here for LC prime, right? And let's see where we get. I'm going to keep copying and pasting the same. I go right here. Note that we have TC prime A and TC prime A here, right? So we going to need we will need to square. I'm going to pass the c to the other side, c speed of the light. I am going to pass the 2 to the other side as well. See, we have Tc prime here and Tc prime here. Let's see if we can get an equation just for Tc prime A. We have to square both sides. Both sides of the equation to get rid of the square root. Okay. Here you go. Square. Square. Go. Square of 2 is 4. Oops. So we're getting there. Huh? It looks like we will be able to write an equation for Tc prime with respect to A. Here is 4. Get rid of that stuff. Here you go. Yeah, I can pass that to the left side. C is going to be always going to be greater than VB of A. Okay, so we can here write our equation in terms of Tc prime A. I'm going to put Tc prime A in evidence and 4 as well. Let's see how we're going to do that. You know what? No, we already did that, right? Let's see if I can. Okay, let's. Is the c square and the v prime that, and the v square that will. I'm gonna put the c right in here. Right? I'm going to put the v right in here. This term here is going to be in evidence, right? So the way we do it is like that. And then we get rid of this one here. We go for another step. And the step is going to be 4 here. Right? 4, we don't need the 4 in the left side anymore because I pass it to the right side. We don't need the parentheses anymore either. All we need now is the square root. Gotta take the square root of both sides. And when we do that, TCA, and then I put the prime later on. We can do better than that. We can put the 2 and the d on the outside of the square root. Let's see if we can do better than that. Yeah, there is one more thing that we can do to simplify to put this equation in the standard format, okay, I'm going to put the C squaring evidence. When we put the C squaring evidence, we end up just with 1 minus this ratio. And now I can take my C from the on the outside of the square root. Here you go. Now we must recognize something here. We must recognize that 2 over C, see, 2D over C is the period of the clock as measured by an observer in referential B, right? So here you go. We can place it right in here. And we have this fancy square root, which, by the way, shows up very frequently in relativity, this term here. Okay. Let me here write that in a different way. It's going to be square root of 1 is 1, right? So I don't need to keep my square root there in the 1. And all we have to do is to divide TC prime B by this square root. This term that you see here, 1 over. Now we can clearly see that TC prime A is greater than TC prime B. Okay, we can see that clearly. Why is that? Because, let's see, this term that you see right in here is going to be less than 1. Okay, this ratio is always less than 1. This ratio is always less than 1. It's going to be positive as well. Greater than 0, less than 1. Consequently, this term that you see right here is going to be less than 1 as well. 1 divided by the number that is less than 1 is going to be a number that's greater than 1. Because this number here is going to be greater than 1, TC prime A will always be greater or equal than TC prime B. So the period that the observer A measures for the clock that's moving is going to be always greater than the period that the observer in B measures for the same clock, the clock that is at rest with respect to him, okay? And we have the final equation here. Okay, that ratio, like I told you, appears very frequently in relativity. Because it appears very frequently in relativity, we give it a name. We call it gamma, the gamma factor. The gamma factor is always greater than 0. You can plot this equation here against VBA over C. It's possible to do that for different values of VBA. Okay, for different values of this ratio. When this ratio is 1, it means that the velocity of the referential is equal to the velocity of the light. Let's plot that. I'm going to get my raster right here. It's not difficult to do that. Raster. Okay, relativity. I'm going to put it here. Relativity. Am I sharing the screen, by the way? Yeah, I'm sharing the screen, right? Let me see. Am I recording? Yeah, I'm recording. Good. Let's zoom in. Go back to the equations. I'm gonna share, here you go. And that's my spreadsheet. The most convenient way of plotting this equation here would be to consider the VBA over C as being our variable, okay? I'm going to even put it in a slightly different format. VBA is velocity of referential A with respect to B, which, by the way, coincides with the velocity of the clock, C prime, right? With respect to A. I'm going to just here you go. I'm going to plot against this ratio here. This ratio can be anywhere between 0 and 1. Okay. And even better, what I'm going to do, I'm going to plot, not only I'm going to plot against this ratio, but I am going to, the y, right, value is going to be this other ratio here. If this ratio is greater than 1, TCA, oh, by the way, it's not TCA, it's TC prime A, right? The prime is just to remind you that the clock is moving with respect to the main referential A. Gonna be TC prime here, TC prime here. Now let's plot it. VBA over C, T C prime A divided by T C prime B. That should be subscripted. That should be subscripted. That should be subscripted. Okay. Okay. This ratio can be anywhere between 0 and 1. Let's see, I'm going to start with 0, 0.5, okay? 0.5, no, I don't want 0.5, I want 0.05. Let's see, yeah. Or 1, 2, 3, 4. Yeah, I think that is the right. Yeah, that's a good ratio. And the TC prime A over TC prime B is equal to what? Is 1 divided by square root of 1 minus this value here, the square. Okay? When the clock of C prime is at rest, the ratio TC prime A, TC prime B is equal to 1. Whatever clock, whatever the observer in A sees for clock C prime is the same value, is the same period that the other observer in referential B measures. However, as the speed keeps on increasing, right? The time dilation becomes more and more perceptible. At 90, here you go is 5% the speed of the light. Here is 10% the speed of the light, 15%, and so on. Here is 95% the speed of the light. Okay, and we can go to 0.99. Let's see what we get. 0.99, 7 times, right? And then we can plot it. That's how it looks like. That's how gamma looks like. And we can insert, add chart element. That's exactly what you're supposed to do in the labs, right? Axis title, primary horizontal. Yeah, primary horizontal is going to be VBA over C. BA should be, I'm going to make it larger, 20, and make it boldface as well. I'm going to do it subscript. And we can also do italics. Italics for V, italics for C. I'm going to increase number, let's see, number here. I want to make it larger. To make it larger, let's see here. Okay, let's put it 14. Yeah, and I also want to make it bold-faced. Body, okay, bold-face. Good. Here we do the same thing, 14 size. Number, font. Tick marks label, let's see, font should be here, right? 14, yeah, bold-face, but we do not need 2 decimal places. We need the 0 decimal places, right? 0 to 4, and we have to add our chart element, axis title, primary vertical. That's going to be TC prime, TC prime A over TC prime B. I'm going to make it size number 20. Bold-faced, and then we have to come up with the subscripts. Subscript here and subscript here. Font. Bold, italics. Italics. Do we have bold here? Yeah. That's what happens. That's what happens in real life, okay? The closer you are to the speed of light, the larger is the time dilation. I'm going to, instead of, okay, 1.5, we gotta go just to 1. V cannot be greater than C. That's how the period of the clock changes with the velocity. Okay? And I'm going to copy this thing here and snipping tool. Snipping tool, here we go. Copy that and paste in the notes. What did I do here? Let's see here. Yeah, okay. What I want to do, let's see. I want to keep this guy right in here. I can delete that. I don't need that anymore, right? And the other graph, well, what did I do with the other graph? Oh yeah, this one here that I want. I can place it right in here. And now we can start our lab. That's the problem of time dilation. You should be able to solve some problems given this treatment. Okay, and let's get the syllabus. Let's see, someone is sent me a message. Okay. Sorry, you couldn't open. Why is that? Huh. Let's try it in another way. College, Harbor, 2026, spring, syllabus.